Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I would love to discuss the innovative programming model introduced in the study. Could you provide more insights into how DSPy abstracts language model pipelines as text transformation graphs and how it differs from the traditional hard-coded prompt templates used in existing pipelines?
Absolutely. In the study, DSPy introduces a new way of looking at language model pipelines by abstracting them as text transformation graphs. Imagine you have a magic wand that can turn a plain rock into a shiny diamond by following a set of steps. Similarly, DSPy helps organize the steps needed to transform text by using a structured approach. Now, when it comes to how DSPy differs from traditional hard-coded prompt templates, think of traditional templates like following a strict recipe for baking a cake. You have to follow each step exactly as written. However, with DSPy, it's more like having a general idea of what you want to bake, like a cake, and then figuring out the steps as you go along based on the ingredients and tools you have. It's more flexible and adaptive compared to the rigid structure of traditional templates.
That's a fascinating analogy. It seems like DSPy provides a more dynamic and adaptable framework compared to the rigid and fixed nature of traditional hard-coded templates. Could you elaborate on how DSPy modules are parameterized and capable of learning how to apply compositions of techniques like prompting, fine-tuning, augmentation, and reasoning when constructing language model pipelines? How does this learning capability enhance the efficiency and effectiveness of the pipelines created using DSPy?
DSPy modules are like building blocks that can be customized and combined to create complex language model pipelines. These modules are parameterized, which means they can adapt and change based on the specific task they are assigned to do. It's like having different types of Lego pieces that can be put together in various ways to build different structures. When constructing language model pipelines using DSPy, these parameterized modules are capable of learning how to apply compositions of techniques like prompting, fine-tuning, augmentation, and reasoning. This learning capability is similar to how a chef learns new recipes and techniques over time, becoming better at cooking different dishes. This enhanced learning capability of DSPy modules makes the pipelines more efficient and effective, just like how a skilled chef can create delicious meals faster and with better taste. DSPy's modules can improve the quality and performance of the language model pipelines they are a part of. By learning from past experiences and adjusting their parameters, these modules can optimize the pipelines for specific tasks, leading to better results in natural language processing.
It's intriguing how DSPy's parameterized modules act as flexible building blocks that can adapt and improve with experience, similar to how a chef refines their cooking skills over time. This adaptability and learning capacity seem to be key factors in enhancing the efficiency and effectiveness of language model pipelines created using DSPy. Moving on. The study mentions the design of a compiler in DSPy that optimizes pipelines to maximize a given metric. Could you shed some light on how this compiler works to improve the performance of DSPy pipelines, and what specific optimization strategies are employed to achieve this goal? How does the compiler contribute to the overall success of utilizing DSPy in developing advanced language model pipelines?
In DSPy, the compiler plays a crucial role in improving the performance of pipelines by optimizing the programs created in this programming model. The compiler uses a teleprompter, which is like an optimizer, to enhance the quality or reduce the cost of the modules within the program. The compiler goes through 3 stages to optimize the program. 1. Candidate generation. The compiler identifies unique predictors in the program and generates candidate values for their parameters. These values include instructions, field descriptions, and demonstrations, which are example input-output pairs. 2. Prompting. The compiler uses these demonstrations to prompt or fine-tune the modules within the pipeline. This process is inspired by PyTorch abstractions and allows for the creation of define-by-run computational graphs. 3. DSPy. Compilation. The compiler then optimizes the DSPy program by simulating different versions of the program on training inputs, creating example traces for each module to improve self-improvement. This optimization is done using teleprompters, which are general-purpose strategies for improving programs. These teleprompters employ various optimization strategies to enhance the performance of the pipelines. One strategy is bootstrapping example traces for self-improvement, which helps in constructing effective few-shot prompts. Another strategy involves fine-tuning small language models to improve the efficiency of the program. Overall, the compiler in DSPy contributes significantly to the success of utilizing this programming model in developing advanced language model pipeline. By automatically optimizing programs and utilizing teleprompters for optimization, the compiler enables researchers and practitioners to build high-quality pipelines quickly. This approach of self-improvement through compilation in DSPy contrasts with manual prompt engineering in traditional implementations, leading to more efficient and effective language model pipelines.
The compiler in DSPy seems to act as a powerful tool that optimizes language model pipelines by enhancing the quality of modules within the program. The three-stage process involving candidate generation, prompting, and compilation, along with the use of teleprompters for optimization, showcases a sophisticated approach to improving the performance of DSPy pipelines. The utilization of various optimization strategies such as bootstrapping example traces and fine-tuning small language models highlights the compiler's ability to enhance the efficiency and effectiveness of the pipelines. By automating the optimization process and focusing on self-improvement through compilation, DSPy offers a more streamlined and effective way of developing advanced language model pipelines compared to traditional manual prompt engineering methods. This innovative approach not only accelerates the pipeline development process, but also enhances the overall performance and quality of the language models created using DSPy. Thank you for providing such detailed insights into how the compiler in DSPy contributes to optimizing language model pipelines.
The compiler in DSPy optimizes language model pipelines by using a teleprompter, which acts as an optimizer for DSPy programs. This teleprompter goes through 3 stages to improve the quality or cost of modules within the program. 1. Candidate generation. In this stage, the compiler identifies all unique predict modules in the program. For each predictor, the teleprompter generates candidate values for parameters, including instructions, field descriptions, and most importantly, demonstrations, example, input-output pairs. 2. Bootstrap fine-tuning. The teleprompter then uses a process called bootstrap fine-tuning to further optimize the program. It simulates versions of the program on inputs, constructs example traces of each module for self-improvement, and uses them to create effective prompts or fine-tune small language models within the pipeline. 3D. Compilation. Finally, the compiler optimizes the program using the teleprompter to improve its quality or cost. It takes the program, training inputs with optional labels, and a validation metric as inputs. The teleprompter determines how to optimize the program by iteratively improving and refining the modules based on the examples and demonstrations gathered earlier. These strategies are employed to maximize the performance of the modules within the program by continuously refining and improving them based on examples and demonstrations, ultimately leading to a more efficient and effective language model pipeline.
Thank you for breaking down the process of how the compiler in DSPy optimizes language model pipelines using the teleprompter. The detailed explanation of the 3 stages, candidate generation, bootstrap fine-tuning, and compilation, provides a clear understanding of how the compiler enhances the quality and efficiency of DSPy programs. The use of bootstrap fine-tuning to simulate and refine the program versions, along with the iterative optimization process during compilation, demonstrates a systematic approach to continuously improving the modules within the pipeline based on examples and demonstration. This methodical refinement contributes to maximizing the performance of the language model pipelines created using DSPy, ultimately leading to more effective and efficient natural language processing tasks. By leveraging these strategies to refine and optimize the modules through self-improvement, DSPy offers a groundbreaking approach to developing advanced language model pipelines. This emphasis on continual learning and enhancement sets DSPy apart as a versatile and powerful tool in the field of natural language processing. Thank you for highlighting these crucial optimization strategies employed by the compiler in DSPy.
In DSPy, the compiler plays a crucial role in optimizing language model pipelines to enhance their performance and efficiency. The compiler in DSPy employs various strategies to achieve this optimization. 1. Candidate generation. Wow. The compiler first identifies all unique predictors, predict modules, in a program. For each predictor, the teleprompter generates candidate values for parameters, including instructions, field descriptions, and demonstrations, example, input-output pairs. This process helps in exploring different possibilities and refining the modules within the pipeline. 2. Teleprompters. Teleprompters are general-purpose optimization strategies used by the compiler to improve the quality or cost of programs. They go through 3 main stages. In the first stage, candidate values for predictors are generated. Then, in the second stage, these values are refined through prompting or fine-tuning. Finally, in the third stage, the program is optimized based on the chosen values. This iterative process helps in fine-tuning and improving the pipeline's quality. 3. Modular optimization. The optimization process in DSPy is highly modular. Teleprompters are used to determine how to prompt or fine-tune individual modules within the pipeline. By optimizing each module independently, the compiler can enhance the overall performance of the program. 4. Bootstrapping example traces. The compiler uses a few training inputs with optional labels and a validation metric to simulate different versions of the program. It then bootstraps example traces for each module to enable self-improvement. By utilizing example traces, the compiler can construct effective prompts and fine-tune small language models at various steps of the pipeline, leading to better program efficiency. Overall, these strategies employed by the compiler in DSPy help in systematically optimizing language model pipelines. By refining individual modules, fine-tuning parameters, and continuously improving the program through prompts and demonstrations, the compiler contributes to enhancing the performance and efficiency of programs created using this programming model.
The optimization strategies employed by the compiler in DSPy shed light on the sophisticated approach taken to systematically enhance the performance and efficiency of language model pipelines. The emphasis on candidate generation, the use of teleprompters for general-purpose optimization, and the modular optimization process exemplify a robust framework for refining and fine-tuning programs within the pipeline. The iterative nature of the optimization process, coupled with the bootstrapping of example traces for self-improvement, demonstrates a commitment to continual learning and enhancement within DSPy. By enabling individual module optimization and parameter refinement, the compiler plays a pivotal role in elevating the overall quality and efficacy of language model pipelines developed using this programming model. The compiler's ability to construct effective prompts, fine-tune small language models, and optimize programs based on chosen values showcases a dynamic and adaptive approach to optimizing pipelines in a systematic manner. This comprehensive strategy contributes significantly to the success of DSPy in creating advanced and efficient language model pipelines for various natural language processing tasks. Thank you for outlining these key optimization strategies employed by the compiler in DSPy.